Hey everybody, this is going to be a relatively short video today, so stay with me. Let's get moving. We're looking at triangle relationships, chapter 5. Today, concept number 3, triangle inequalities. So let's get started. Okay, so the basic concept is here that we're going to be looking at is three sides given to you, three segment lengths, and we want to know, does it actually make a triangle or not? So it's going to come down to a similar premise like this, where we have a 1, a 2, and a 3, let's say, and the gray represents kind of the upward and downward movement of those 1 and 2s as we're trying to build a triangle. So the problem with this scenario is that when we bring the 1 and 2 down to meet with the 3 so that it's level with it, they touch because 1 plus 2 is 3. It's the same length. But as soon as we lift it up, it creates an opening and no longer a triangle. These two sides are just too short to create a triangle given that third side of 3. So let's look at coming up with an understanding of this a little bit in more detail. So we have the triangle inequality theorem, and it basically says this: the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now, if that just became a big, huge list of words in your head and you didn't have an understanding of what that meant, as always, you should put me on pause and take a look at that and make sure you understand what those words mean. I'm going to pause for a second and let those people who need to put me on pause, and then come back and we'll continue. Okay, so hopefully you understand. Basically what it's saying is if I grab any two sides, it has to be greater than a third. That's what those three inequalities represent. So the x and y is my orange side, y and z is my blue side, and xz is my red side. So if I grab the orange and the blue, it has to be greater than the red. Now the other two inequalities basically are the same thing, and what it comes down to is, let's suppose this was a side of 3 and this was a side of 5. What it's saying is it can't equal 8 for this third side. That when I add the 3 and the 5 together, they have to be longer. The third side has to be longer than the sum of those two. So 8.1 would be just enough to get me over and create a triangle. Okay? Anything greater as well. 10 would work and so on. Now what we find out is actually that third side can become too big, and that creates a problem on its own. So let's take a look at this in a little bit more detail. This idea is pretty basic, and you probably already have an intellectual understanding of it. Basically, it says this. If I'm looking at going from X to Z, let's say from my house to a school, it's a certain set distance, okay? Now, if I was to drive up to my friend's house and then to school, those two lengths added together have to be longer than going from home directly to school. Mom, Dad probably told us a long time early in our years that the quickest distance between 2 points is a straight line, and that is for sure. If I go go from my home to my friends to the school, it's got to be a longer distance. So the first I can statement says if I can determine if a triangle really will create the lengths, create a triangle given 3 lengths. Okay. So in this black writing here, I have 3 sides, a 5, 8, and 4. And before, I'm going to take those 3 inequalities, I'm going to test them. Okay. So let's start. I'm just going to grab 5 and 8. And I'm going to add them together, and then I'm going to ask myself, is that greater than the fourth side? That equals 13, and certainly 13 is greater than 4, so we'll put a check mark next to that. Now I'm going to go ahead and go through this work and show you the other two, and I hope that you take notes on this. What I want you to know is I'm showing you how I expect you to respond to questions like this. You can write sentences or whatever, but I'm showing you exactly how I want you to respond to this. You're going to write 2 sides added together greater than the third side with a question mark over it. And if it's true, then you put a check mark next to it. If it's not, you put an X next to it, and that basically says that it's not possible as a triangle. Okay, let's continue. So now I'm grabbing the other 2 sides. Let's simplify that and call that 12, and certainly 12 is greater than 5. So let's put a check mark next to that. Now the only pair I haven't dealt with is the first and the last, so we'll put those together and ask, is that greater? Notice I'm putting the question mark above each one of those because I want to make sure that I'm not saying it is or it isn't. I need to just check it. Okay, so 9 is greater than 8, and so I'll put a check mark there. Now, many of you are probably saying, oh, I can do this stuff in my head, Mr. Munson. I want you to know that we're headed to much more difficult ideas and concepts, and we're going to use the same idea then. So you're practicing what I'm having you do today. I'm having you practice that, so when you get to in a little bit more difficult scenario, you have the basic setup set down. Okay, so make sure you do your problems tonight on your homework this way. Unless, of course, you happen to know a shortcut, which I'm getting ready to show you. Basically, the shortcut is this. Of those three inequalities I just showed you, there's one special one that if that one is true, then the other ones are forced to be true. And you can see me if you really want to know why. But it basically comes down to this. So instead of showing three inequalities, you only have to really show me one. The one is you grab the two smallest lengths, add them together, and verify, is that one big enough? Okay, so let's put a question mark there. This reduces down to 7, and 7 is not greater than 7, so this fails. Okay, so if that actually worked, I'd say, okay, that's going to be a triangle. Okay, and I'd answer, yes, this is a triangle. Okay, so this is enough now. This is a shortcut if you watch this. Now here's another one, and I've already done the work for it, so as you can see. But what causes us some trouble with this is it's an isosceles triangle. It could possibly be an isosceles triangle. We don't know yet. But when we're looking at doing the shortcut on this one, we said, hey, grab the two shortest sides. Well, here's a problem. I'm not sure which ones are the two shortest sides. So if that causes you confusion, then what you'd want to do is, again, do it under brute force. That means you show all three inequalities, and you're always safe if you do that, okay? So if you're not sure how to use the shortcut on a particular problem, show all three inequalities, put check marks next to the ones that work, put an X next to the one that doesn't, and if you see an X, then it's not a triangle, okay? All right, so here's another I can statement. It basically says determine the range of third sides. So the range that the third side can be given two sides. So in this case, I'm given a 9 and a 5, and I'm looking for how big and how small that third side can be to still create a triangle, okay? So the way we're going to do this is we're going to call X my third side, and I'm going to put a less than on the left-hand side and a greater than on the other side, okay? So basically the two are pointing to the left. Okay, actually two less than signs. I apologize. And so what we're going to do is we're just going to take the two sides we're given, and we're going to do 9 minus 5 on this side, and then guess what the other one's going to be. You got it, 9 plus 5. Okay, so we end up with X being trapped between the numbers 4 and 14. If you find that you have a side, somebody says, okay, I want the third side to be 22. It can't work with a 9 and a 5, okay? Because it's too big. Any number that's in between 4 and 14 works. 4 does not work, 14 does not work because it's not in between it, but 4.1 works, 13.9 works. This is if it's going to be too small, it can't be over here, and these are too big, okay? Very good. All right, there's your try it problems. Make sure you put your title at the top, set up your paper properly, and bring this next class.